Hi class, I hope you are doing well today. Today what I want you to be focusing on is lesson 9.1.5 and how can you measure angles. This is, I think, kind of a neat little lesson. The main objective is to help us learn a new concept of what we call radians. And kind of where do radians come from and what are they? And radians is really just another way to help us out with measuring circles. To give us some backstory, up till now we have really focused on degrees, and we have used degrees a lot to do various calculations. And a question you may have asked yourself is, have you ever thought of where did these degrees come from? Where did they originate? Who thought up this concept that there should be 360 degrees in a circle? I don't know if you've ever thought about that, but that idea of using 360 degrees in a circle dates back almost 4,000 years to the Babylonians, which are in modern-day Iraq. And that's where this idea of degrees came from. And part of that is because the Babylonians used a numbering system that's kind of based on a base 60 numbering system. Right? We're used to using a base 10 numbering system mainly. And so that's 360 comes partly off of the numbering system. Also, some thoughts there with why 360 is because for the Earth to circle the Sun took 365 days, and so 365 is kind of a harder number to manipulate, but this 360 is an easier number. So just with some rough rounding, it's thought that they use this number to help with approximating some information and would be easier off of the numbering system. So we have used degrees, but that's not the only way to measure and look at circles. And so what we're going to mainly look at today is what we call radians. And I'm going to watch a little animation here to help us see where do radians come from and how do we get them and what exactly are they. And so this animation is running, so let's just give it a moment. And so what we're going to be looking at is we will start out with a radius. We'll start out with some distance, and we will draw a circle, right? And we'll take this radius and we'll take it and we'll put it outside onto our circumference. Now, the angle that is created between the end of this radius that we put on, that angle we call 1 radian. Okay, and we can see that. Okay, we can get 1, 2, 3, and then a pi radians to make up half of a circle, or to make up a full circle, we make 2 pi radians. So once again, we'll run through this animation just to kind of see where the idea of radians come from. So we take our radius in red here, and we take that radius, put it outside onto our circumference, and the angle created by the endpoint of our radius is called 1 radian. Now we got 1 radian, 2 radian, 3 radians, then pi radians. So pi radians makes up half a circle. So in other words, that's 3.14 radians. Or for a full circle, we got 2 pi radians. And so this is another way that we can use to measure different spots on a circle. And we'll continue to be looking at radians as we go through some things here. So with that in mind, what I'd like you to mainly focus on now is focus on questions 61 through 64 for today's work. And then, of course, the review and preview problems are tasked with the homework, or with the lesson. So, some basic questions about circles. It asks also, though, tries to have you think about, well, how many radians are in 360 degrees, or how about 90 degrees? And so you might want to think about, is there some way that you can try to use to do some sort of conversion between these two concepts? So let's just look at 90 degrees real quick as a class, and then hopefully this will help you with different problems you may come across also. So if I have 90 degrees and if I want to change that into radians, this is a unit conversion thing, and so I'm going to multiply it by something that will help me eliminate this degrees. And so let's multiply it by 180 degrees. And as we saw in that little animation, 180 degrees, right? We know that's half a circle, but we saw from that animation that is also what we call pi radians. And so through this process, right, we could get 90 degrees times pi over 180 degrees. Well, the degrees are just going to cancel out, and 90 over 180 simplifies, so we can have pi over 2 radians. So we'd say we have pi over 2 radians, or pi half radians, and that is the same as 90 degrees. And so continue this. 63 is going to want you to kind of draw different circles, so it jumps in between degrees and radians, and wants you to kind of figure out where those different measurements are on a unit circle. And after you get 64 done, just focus on the homework, and I hope you have a great day. Talk to you later.